Hey guys, Mr. McKinney here, just going through the second piece on our piecewise functions. So now we're going to start with a graph and we're going to work backwards and figure out what equations would model this graph. So the first thing you're going to want to do is figure out where does the graph break? Where does it switch from one function to the other? And on this first graph that we're looking at here, you can see that it switches from this function on the left side that looks like a quadratic to this function on the right side that looks like a square root function. And the x value where that happens is at 0. So when I write this equation, I'm going to say f of x equals, and then I'm going to have two separate domains. And the breakpoint was at 0. Now in this case they meet at the same place, so I can define either x is less than 0 and x is greater than or equal to 0, or I can put the or equal to here. Because they meet, it does not matter. I'm going to get the exact same answer either way, so whichever way you prefer. If one of them's colored in and the other one's not, like we had on these examples, then it does matter. But if they meet in the same place, then you can just put it on either of them. And so now I just need to figure out what the equation is that models each of these. Now this first one has some curves in it, so it's a little bit trickier, but all the ones that I'm going to expect you to do are going to be linear, which is what the next couple of examples will be. So this first graph that I'm looking at over here, which is going to end up being the top one, because that's when x is less than 0, over this way is less than 0. If I look at this graph, it's got 0, 0, 1, 1, and 2, 4, or really negative 2, 4. This is a quadratic graph. So the function over here, it's part of my parabola, but we're only looking at the left half of it. That's what we've got graphed. So the rule is y equals x squared when x is less than 0. And on the right side, which I'll do in red over here, it's similar, but instead of being an x squared graph, this one's the inverse of that. It's a square root of x graph. So we think about the square root of x starts at 0, 0. Square root of 1 is 1. Square root of 4 is 2. So the rule for this one on the right side, going to the right, when x is greater than or equal to 0, is the square root of x. And I can check, if I plug in 0, I get 0. If I plug in 0 here, I get 0, which is why I can put this bar on either of them. I don't want to put it on both of them, but I could put it on either of them. All right, like I said, this first one had curves. The rest of them are going to have linear functions, and I expect you to be able to do linear functions, not necessarily be able to do the curvy ones. All right, now let's take a look at this one. There's more than one way to handle this. Most of you guys will treat this as 3 different lines, so that's the way I'm going to show it, and I'll talk about the other way you could do it in a few minutes. So we need to look for the breakpoints first. In this case, there's a breakpoint here, and that one's pretty obvious because we can see that the function breaks. There's also a breakpoint here because I go from a negative slope to a positive slope. This breakpoint is happening when x is negative 2. This breakpoint is happening when x is 0. So when I set up my function, I know that first of all, I'm going to have 3 equations. One that's less than negative 2, one that's between negative 2 and 0, and then one that's greater than or equal to 0. Now, at this origin point, it's colored in, so I'll be able to put the less than or equal to in either place when I talk about 0. But because the point is colored in down here at negative 2, going to the left, I'm going to make sure that the less than or equal to, or the or equal to, goes with the less than, not the greater than. And I'll explain that again once I start writing it out. All right, so for my domains, over here on the left side, I would say when x is less than or equal to negative 2. And again, I need to put the bar here because going to the left is where it's colored in. Then I'm going to go between negative 2 and 0. So I'll say negative 2 is less than x is less than 0. And then I'm going to the right of 0. So that would be x is greater than or equal to 0. Now this bar could have been here. That's the exact same thing because they meet at a colored in dot. This one needs to be on the less than because that's where the colored in dot is. So now let's come up with our 3 separate equations that model this. Now again, I'm expecting you guys to be able to do linear functions. And when we talk about a linear function, it's going to be in the form y equals mx plus b, where m is our slope and b is our y-intercept, or where it crosses the y-axis. So let's take a look at this line over here that I've circled in yellow. I can see the slope pretty easily. The slope is 1. I'm going up 1 over 1, up 1 over 1, up 1 over 1. I can't see the y-intercept until I just extend it a little bit in my mind. So to get over here, it turns out that the y-intercept is at 0. So the slope is 1, y-intercept is 0, so this would be just x. So when x is less than or equal to -2, the rule is just x. So let's do a quick check. When x is -5, y should also be -5, and I have that point. I have a point at -5, -5. So now let's look in between my two breakpoints. So from when x is -2 to when x is 0. So again, it's a linear function. This time, instead of having a slope of +1, we've got a slope of -1. We're going down 1 over 1, and we can see where this one hits the origin. It hits the origin, or sorry, we can see where it hits the y-axis. It's at the origin. So we can see that this one has a slope of -1. So instead of +x, it's -x. And then I don't have to worry about doing plus or minus anything because the y-intercept is 0. And then for the last function, we're looking at this one over here. Again, we're looking at slope first. Slope is 1, so I know I'm going to have x. And then because we met at the origin, it's just x plus 0, which I'm just going to write as x. And if we think about it, I could have connected these two. Like, these are all really part of the same function. That's why we have an x here and an x here. Whereas this one, in between -2 and 0, is a different function. It's -x. I know this got real messy, so either back the video up or in a second I'll show a cleaner version of it. Let's do one more of these. All right. So again, we've got 3 different pieces. We've got a piece coming in from the left, and then we have 2 different slopes here. So even though they're both straight lines and they're both going up, we have to come up with a different equation for each of these because the slopes are different. So I'm going to look for the breakpoints. In this case, we've got a break at x equals 0 and a break at x equals 2. So when I set up my equation, I'm going to have 3 rules. I'm going to have one rule for when x is less than 0, one rule for when x is between 0 and 2, and one rule for when x is greater than or equal to 2. Now, because everything meets at a colored in dot, I can put the less than or equal to's wherever I want. Not the less than or equal to's, but the or equal to's, the bars that go underneath it. So one of my rules needs to be for when x is less than 0. One of my rules needs to be for when x is between 0 and 2. And one of my rules needs to be for when x is greater than 2. Now, because they meet at colored dots, I need to have the bars somewhere. So I can either do a bar here and here, or I could do both of the bars here. It doesn't really matter. You should have one bar next to the number 2 and one bar next to the number 0. As long as they meet at the same point, it doesn't matter where you put them. So now, again, we're thinking about y equals mx plus b, the formula for slope, or slope-intercept. We've got our slope, we've got our y-intercept. So let's go through these lines one at a time. Starting on the left over here. So I'm doing this one in green. Slope, down 1 over 1, down 1 over 1, down 1 over 1. So my slope is -1, and then my y-intercept is also -1 for this green one. So -1x minus 1. My y-intercept was -1, and my slope was -1. All right, let's move to this middle piece. Now for the middle piece, where slope is not 1 because I'm not exactly on either of the boxes right here. So I got to find 2 points that I can see and then find the slope going between those 2. So in this case, up 3 over 2. So rise over run, my slope is 3/2, so 3/2 x, and then the y-intercept is the same thing for this one. My y-intercept is -1. Now for this last one, I'm looking at this piece over here. So let's switch to yellow. Before I do that, let's color in red here. Switch to yellow. Now we're back to a slope of 1. So it's just going to be x, 1x. Now I got to figure out what the y-intercept would be by working backwards. So the y-intercept for that one would be 0. If I think about this line extending a little bit, it would hit at 0, so plus 0. And I can do a quick spot check. So if I plug in 3, my y value is 3. When I plug in 4, my y value is 4. And that makes sense. The function y equals x, the x value and the y value are always the exact same thing. Now, whether I plug 2 in here and I get 2, or I plug in 2 here and I get 3/2 times 2, which is 3 minus 1, I'm going to get 2 either way. They meet at this point. So you can put the bar here or here. Either way is fine. All right, that's going to wrap up the second part of our video. We're going to get a little bit of practice on evaluating and a word problem in the last video. Hope this is helping.